Goldsmith, and this is my Physics 2212 Lab 3 on the bar magnet. So the introduction to the purpose and preview of the result. The purpose of this lab was to understand the relationship between the distance from a bar magnet and its magnetic field by taking measurements of the magnetic field at different distances and then to simulate the magnetic field and compare the results. So we found the preview of the result is that mu, the magnetic dipole moment, we found to be approximately 1.1 times 10 to the 7th, which is not like a realistic number, which means that our measurements were probably impacted by human error. And with the relation to the stated goal, we did, however, find that the magnetic field on average decrease as distance increased from the magnetic dipole. So some of the models and fundamental principles we used were the strength of a magnetic dipole field anywhere in the field is given by this formula here, and the magnetic dipole field strength on axis, mu naught over 4 pi times 2 times mu, which is the magnetic dipole moment, over r cubed, the distance from the dipole. And then here we have just another formula for the distance for the dipole field strength on axis, given by k r to the n, where k and n are constants, and r is the distance away from the field. And then this is another derivation. This is a derivation of this formula. So some assumptions and error causes are that I assume my phone has an accurate magnetometer, and I assumed that no changes in the magnetic dipole moment are made, and the measurements stay on axis as we move away for this formula and throughout the experiment. And some error causes were that the measurements were taken by me and my lab partner, who were humans, and any small movements off axis could make major changes in the measurements, and there were a lot of electronics and other sources of error in the room when the measurements were taken. So the lab procedure was to find the magnetic north by zeroing the x component in the magnetometer map, I don't know how to pronounce that, and to find the magnetometer within my phone by moving vertically then horizontally with respect to the bar magnet to maximize the magnetic field. Take multiple distance measurements of 5 specific magnetic field strengths from the magnet. Take measurements of the magnetic field strength 45 degrees off the point on the axis where the field strength is 100 microteslas, and simulate those measurements in GlowScript and compare the results with the two. So our on-axis measurements are given here in these yellow places where we show the magnetic field strength that we see and the approximate distance away from the magnet that we were at that point, and we can see that these are linearly related. These are our off-axis measurements here. The Earth will always have a magnetic field in the y-axis in Atlanta of approximately 49 microtesla, so we accounted for that and subtracted that from our y component of our magnetic field. And then here, using the formulas we had on the other page, the natural log formula over here, there's a derivation. We can, in subbing in for the natural log of k and n, which are constants, which we know from on the previous slide here, the line of best fit, we were able to find that mu, the magnetic dipole moment, was equal to 1.1 times 10 to the 7th, which, as I said, doesn't really make sense, but it's what we got. So here's the coding in GlowScript. We entered in the magnetic field, the magnetic dipole moment that we got, and then we also added in the perpendicular distance that we used, and then up here we add in the formula for the magnetic field from a dipole at any point in the magnetic field, and which we use down here to calculate a vector for the magnetic field at the 45 degrees off axis point. Here are our results. As you can see, we have our arrows here representing the different points in the magnetic field, and we have our results here, which are slightly different, but not that different from the results we got in person. So yeah, what if you hadn't created the experiment to compensate for magnetic north and had laid out the meter stick at some intermediate angle with respect to the Earth's magnetic field? How would your results have changed? We would have inaccurate results with regard to the bar magnet strength because of interference from the Earth's field. And if we were to stick two identical magnets together end to end and run the experiment again, how would our measurements differ? I would expect that the magnitude of the magnetic field would double, assuming that the two magnets are actually identical to each other, because putting them end to end would double the strength of the magnets. Thank you.